Today's lesson about transformations is going to talk about dilations. A dilation is a transformation in which a figure is made smaller or larger in respect to a point called the center of dilation. Think about when you go to the eye doctor and you have your eyes dilated. That means the pupils become larger or smaller. So dilation is when there's a change of size. They become larger or smaller. The scale factor is telling you how much larger or much smaller the figure is going to become. The scale factor is going to be known as K. I know that they don't know how to spell. There's no K in the words scale factor, but whenever you see K equals a number, that's going to be what your scale factor is. And it's either going to be an enlargement where it gets larger or a reduction where the shape gets smaller. So let's look at our first problems that we have. It says, tell whether the light figure is a dilation of the darker figure. So a dilation is when something gets smaller or larger. So this first one is, yes, it is a dilation because the light figure was smaller than the dark figure. The second figures, the triangles, are a no because those are just congruent figures. A dilation must show an enlargement or a reduction. So if they're the same figure, what really happened in the second box was just a translation. It slid from one side to the next. Go ahead and try the next two on your own. Now we're going to start plotting points and using a dilation on a coordinate grid. So we are to draw the triangle ABC after a dilation with the scale factor of 3 and identify the type of dilation. So remember, scale factor is also known as K. So K is going to equal 3. So let's look at our vertices in our chart. The vertices are A, B, and C, and I'm just going to go ahead and plot those right now so that we can start this problem. So for A, you go over 1, up 3, and you label your point. For B, over 2, up 3. And then for C, we go over 2, up 1. Then we connect the dots. All right, now what we're going to do next is figure out how to use this dilation. If you have a scale factor, whatever number it is, and in this case it's 3, you are going to multiply all of your coordinates by that number. So let's look at A. For A, we have a 1 times 3, and then we do a 3 times 3. And that's it. You just multiply every number by 3. So when we draw the image, so we have A prime, we're going to have the numbers 3, 9, because 1 times 3 is 3 and 3 times 3 is 9. I'm going to go ahead and plot that point so that we have that ready. So we go over 3, up 9. So I plot that and I write that as A prime. So I'm going to go ahead and do that with B. So for B, I multiply both numbers by our scale factor, which is 3. So I have 2 times 3, and then again, 3 times 3. So when I go to B prime, 2 times 3 is 6, 3 times 3 is 9, and I'm done. So I just have to plot my point. So I go to I go to 6, 9, and that is going to be what B prime is. So now we have our last one of C. We multiply 2 times 3 and then 1 times 3 to find out what our C prime is. This mental math should help you guys. We have 6, 3, and that's going to be our C prime point. So we go over 6 and then up 3, and now we have C prime, and we connect the dots. Now, this purple image is the image. So we have to talk about the type of dilation that we have here. So we either have a reduction or an enlargement. Well, going from the original, which is blue, to the purple, it got bigger. So the type is going to be an enlargement. And I will tell you guys, this problem, this triangle, got exactly 3 times larger than its original because our scale factor was 3. Now we're going to do another problem with scale factor, and this one's a little different because it involves a decimal. It says, draw the image of a rectangle WXYZ after a dilation with a scale factor of 0.5. Then identify the type of dilation. So a scale factor of 0.5. Here's the deal. I think it's easier to deal with scale factor when you have a fraction. Hopefully you guys know your fractions because 0.5 is the same thing as 1/2. So we're going to have our scale factor is 1/2. So that's the number that we're multiplying all these other numbers to. So for our scale factor of 1/2, let's multiply all these other numbers by that. So I have -4 times 1/2, and I have -6 times 1/2. All right, and that's going to give us what W prime is. Now, I'm going to show you the work on this first problem, and then hopefully you won't need it again. So I have -4 times a 1/2. If you're multiplying with fractions, we need both numbers to become a fraction. So we make the 4 over 1, and I hope you remember you multiply across. So we have a 4 times 1 is 4 over a 1 times 2, which is 2. Now we also have talked about integer rules where we have a negative times a positive. Those are opposite signs or different signs, so it is a negative answer. Now, this right here can be reduced to a -2 over 1 or just a -2. So for -4 times 1/2, our first x value, we have a -2 instead. Now I'm going to explain -6 times 1/2 in a different way. When you multiply by 1/2, it is the same as dividing by 2. And I'm going to write that up here. It is the same as dividing by 2. So we could just look at this. -6 divided by 2 is -3. And that's a quicker way of figuring this out. You could go through the whole process of multiplying the fractions as well, but just so you know, you just have to divide by 2. So we have our first points, and we're going to go ahead and continue and fill out the entire chart before we actually graph. So now I have -4 times 1/2, and I have 8 times 1/2 for our x coordinate. Like I said, multiplying by 1/2 is the same as dividing by 2. So -4 divided by 2 is -2, and then 8 divided by 2 is 4. So we have our point for x, and it was fairly quick. Same goes for y. 4 times 1/2, and this time it's positive, and then 8 times 1/2. Again, it is for y prime, 4 divided by 2 is 2, 8 divided by 2 is 4. We're going to finish up with our z. So we have 4 times our scale factor of 1/2, -6 times 1/2. So our z prime is 2, -3, because -6 divided by 2 is -3. Now, you guys can go ahead and plot the points. I forgot to plot my original, so we're going to do that first. So I go to -4, -6 for our W. Please make sure you label. -4, oh, I went to -5, -6, I just realized. So that's the point that we put right there. Then we have -4, +8, and that's going to be x. 4, 8 is y, and then 4, -6 is z. So this is our original figure, guys. These are the original coordinates that we have. Now we're going to do our image, and I'm going to do it in purple. I'm going to circle all the coordinates in purple so you can tell. So for W prime, we have -2, -3, so that's W prime. For X prime, we have -2, +4, X prime. Y prime, we have 2, 4, and then Z prime, 2, -3. Z prime. So they ask for the type of dilation. So we went from blue to purple like in our previous problem. We have to decide, is it a reduction or an enlargement? And because it became smaller, it is a reduction. It reduced. It became smaller. And usually when you have a number that you're multiplying as your scale factor that's less than 1, you will see this reduction happen. Go ahead and try this example on your own. It is a triangle ABC, and it's not written on your notes, but your scale factor is going to be 2. So you get to put on your chart that your K is equal to 2. Just a reminder that all you do is just multiply every single number on your coordinates by the scale factor. So for A, you'll do 1 times 2 and then 3 times 2, and that's going to be the image. Also identify the type of dilation. Tell me if it's an enlargement or a reduction. In this example, you guys are going to finish this on your own. We have a dilation of a scale factor of 1/4, so your K is equal to 1/4. Now, when we had the scale factor of 1/2, I told you that multiplying by 1/2 is the same as dividing by 2. Well, multiplying by 1/4, I'm going to rewrite that. Multiplying by 1/4 is the same as dividing by 4. So you just look at that, the same denominators, right? So when you're looking at all of these numbers, you're going to divide by 4. When you get to this situation of -6, you are going to have a decimal or a fraction. So I'm going to do W with you guys right now, but then you can finish it on your own. So for W, we have -4 times 1/4, then -6 times 1/4. All right, so for W prime, I look at -4 times 1/4. Again, it's the same as -4 dividing by 4. So that becomes -1. We have to remember all of that. Now, I'm going to write -6 times 1/4 on the bottom. For me, it's a little easier if I can just do it as fractions. So it makes -6 into a fraction of over 1, and I multiply across. So it becomes -6 over 4, and I'm going to reduce. I can divide each of these by 2, so it becomes -3 over 2. All right, so if you guys are able to put this into a mixed number, your mixed number is -1.5. Okay, so -6 divided by 4, or times 1/4, it's the same thing, is -1.5. And that's how you're going to graph it. So when you graph -1 and -1.5, you're actually going to be in between numbers. Go ahead and finish this on your own. Make sure you graph both the original and the image of the rectangle. Then don't forget, tell me the type of dilation. Is it a reduction or an enlargement? On these two questions, you are to describe sequence of transformations from the dark figure to the light figure. The light figure is the image. I want you to try to do these, but we're going to actually talk about them in class together so that we can make sure we're all on the same page. Try a little bit to see if you can figure out if the figures were dilated, translated, reflected, or rotated. Now you might do some of both, or some of all four. So go ahead and try it on your own, but we will talk about it as a class.